All right, everybody, let's get started. Thanks so much for joining. My name is Loretta Jones. I'm the VP of Growth here at Acceldata. And thank you so much for joining our webinar to achieve reliability and scale for critical Kafka environments. With me, I have Mark Burnett, who's a Director of Product Marketing, Joe Murphy, who is our Senior Solution Consultant and Subject Matter Expert in Kafka, as well as Shubham Sharma, who's a Solutions Engineer and also another Subject Matter Expert in Kafka. So we do have a few slides to show you today. We're not going to PowerPoint you to death, but we do want to give you just some context on our solution for Kafka, on Acceldata, and then we'll go right into a product demo. And after that, we will take any of the questions that you have. If you do have any questions, please put them in the Q&A box and we will take them at the end of the demo. So without further ado, let me hand it over to Mark.
Great, thanks, Loretta. So on the agenda today, we'll provide a brief introduction to Acceldata and its core mission, which is to provide data observability to the enterprise. And then we'll focus on Kafka and some of its challenges, and we'll highlight how Acceldata can help organizations optimize different aspects of Kafka. We'll provide a demonstration of some key parts of our platform. And finally, we'll save some time at the end for some Q&A. So more and more often, data is being viewed as a product, an asset that's packaged for internal or external consumption. And furthermore, both traditional and new products are becoming smarter with capabilities and insights driven by data and analytics, making them a type of data product as well. In both cases, data products are becoming increasingly critical to the success of business operations. Yet data operations at the enterprise level can be quite complex, and there are many blind spots, potential points of failure, inefficiencies, and other things that introduce excess risk and excess cost. In a nutshell, many data teams lack comprehensive visibility. So data observability is a concept that has emerged to address this lack of visibility. Observability is not merely about more monitoring, however. It's about applying analytics to be able to observe insights into data quality, reliability, performance, efficiency, and other factors. And Gartner's now recognized that data observability is now essential for enterprise data success. And it can be described in 4 parts: observing the data infrastructure that processes and moves data, the data itself that runs on that infrastructure, the data pipelines that are the workflows that orchestrate data and processes, and the associated user behavior and consumption patterns, configuration, and other aspects. And together, this gives teams a multi-layered 360-degree view of data operations. So at Acceldata, enterprise data observability is our focus. And our mission is to enable enterprises to build and operate great data products. Our company's grown at a rapid pace due to the high demand for data observability, the capabilities we've brought to market with our platform, and the expertise and support that we provide to our customers. Note, our founders and many of our engineers came from places like Hortonworks and Cloudera and have many years of experience supporting some of the largest Kafka environments. So while we support many different technologies, in this presentation, we'll focus on data observability for Kafka. Now, Kafka's been around for a while now, and yet, despite that longevity, it is still quite complex, cumbersome, and expensive to operate. One of the biggest challenges for teams that manage Kafka is that service level objectives can be set at a very high bar. And this is because Kafka is often used for mission critical applications where downtime and latency can be very damaging to the business. For example, an hour of downtime for one of our customers can impact over 200,000 of their customers. So it's ensure that they're up all the time, every day. While there are monitoring features in some areas within Kafka, there's still many blind spots, and monitoring alone does not necessarily make it easy to manage. These gaps create excess management overhead in terms of support and maintenance. Kafka requires highly skilled talent, which can be expensive and hard to find. Many organizations will deploy excess resources or over-provision resources as a safety measure to ensure that service level objectives are met, or simply because it's not always clear what's the most efficient configuration. So this combination of excess provisioning, inefficiency, high maintenance, and scarce talent lead to high overall cost, particularly when running at scale. So by default, Kafka has some basic, by default, Kafka does have some basic capabilities, but these are some of the common areas where organizations cite that there are gaps from both a data and a compute perspective. So common data gaps include the ability to easily inspect the actual data inside of Kafka in different ways and from different perspectives. Data quality and reliability monitoring is also important and somewhat more difficult and different when running across a stream. The ability to catalog the data and understand the relationship between producers and consumers across topics, the ability to reconcile data, not just inside of Kafka, but all the way back to source systems, feeding Kafka, and to the final destination that may very well be is likely beyond Kafka. Now, on the compute side, common gaps include the ability to do advanced throughput, volume, storage analysis, the ability to analyze metrics over time, and the ability to create custom visualizations and dashboards for both performance and quality and other measures. And for both data and compute, the ability to generate alerts, trigger external processes, or even execute runbooks that can be used to self-heal and self-tune the system. And these types of auto actions need to have fine-grained controls and thresholds, and they need to respond to trends and anomalies, not just failures. So Acceldata addresses all of these previously mentioned limitations and gaps and blind spots, and making it easy to monitor, analyze, and automate Kafka. We provide comprehensive visibility into the infrastructure, the platform, and even the data flowing through it. And on top of that monitoring, we provide a rich set of analytics, including trending, correlation, and recommendations, and even ad hoc analysis and visualization to provide the insights needed to optimize your performance, quality, reliability, and efficiency. And since time is critical in Kafka environments, we provide advanced notifications on multiple channels, APIs to trigger external processes, and a set of out-of-the-box runbooks that can be used to make Kafka self-tuning and self-healing. And these capabilities can be extended with custom runbooks based on Ansible framework. So the takeaway is that data observability eliminates Kafka complexity by eliminating blind spots. Engineers can achieve greater scale by identifying and eliminating performance bottlenecks. They can make optimizations to reduce infrastructure costs and build trust by delivering high quality data on time, every time. So here's an example of the results that one of our customers has achieved with our data observability platform, support, and services. PhonePe is the #1 payment platform in India, surpassing $1 trillion in transactions on an annual basis. When we first engaged with them, they were experiencing performance issues which were preventing their ability to scale their platform. And 60% of their experienced engineers spent time firefighting operational issues instead of innovating. And this limited the company growth. Since implementing Acceldata's data observability platform, they've had 0 unplanned outages or SEV1 issues for over 18 months and counting. They've scaled their data infrastructure by 13x while meeting their SLAs. And they've saved over $5 million in software licensing costs by leveraging observability on top of open source software. So now I'd like to switch it over to my colleague, Joe, to provide a demonstration of the data observability platform.
Thanks, Mark. So as Mark said, we observe data in We do data observability across multiple dimensions, and we're going to talk about compute and data specifically in this demonstration. And Mark also mentioned, the concept that we have a robust alerting framework, so that, I like to start off with the sense that I'm not living my day within the Acceldata platform. As much as I love it, I know everybody has a day job, so probably your interface could be, hey, I just got an alert, something happened. The system is observing the environments and is alerting me that something happened. So this could be as simple as an email or a notification in a Slack channel. So I just got a notification that I had an execution failure, a failure related to this Kafka trans volume check that I set up. And I can simply click here and I'll be launched into our Acceldata platform. And I'm going to be shown, in this case, the details of a data quality policy that I created that just incrementally is checking to see if new content is showing up on a specific Kafka topic, right? So a very simple check, simple rule saying, hey, as I check this incrementally, I go along, I want to see if there's any new data along here. So I immediately got an error message saying, hey, this has failed, and I can start exploring what's going on in this asset, right? So from our data reliability dimension, we'll treat Kafka and the topics on the Kafka broker as another asset in our landscape. And if I was to pop over and show you all the different types of data sources that we have on this particular platform, I have quite a few of them, including several different Kafka data sources, all of them abstracted to a common metadata model that lets me operate the same way on a Kafka topic as I would on a Snowflake table or a Parquet file out on S3. I can treat them all the same and apply the same type of data reliability measures, right? So I have the concept of being able to apply data quality against this asset, the idea that I can reconcile this asset, maybe from the S3 file that fed the Kafka topic to the Hive table or Snowflake table that consumed that Kafka topic, right? So with respect to this particular asset, I can start taking a look at, gee, what is in this topic, right? I have a view of all of the data columns, right? Or attributes in the messages, right? And it's a little easier to see in this table view. The types of data, I profile the data so I have a sense of, hey, is data null or not? Do I have a high number of distinct values, min, max, statistical averages that I'll build up so I can understand the data in the topic. So I have a much deeper view than just saying how many messages are out there, what's the size, all important information. But if I'm concerned about the data reliability, I have to look inside those messages. So I'm getting a deep view of those messages, and I get it over time. I can look back in time and say, different windows, what did that distribution look like? So I can start doing things like understanding the drift in values of the data. So I can set a policy that says, hey, in this example, these are credit card transactions. I want to know, if I look at the data drift policy, if the source amount, the transaction amount, average amount starts drifting more than 5%, or the maximum that I'm seeing drifts more than 10%, and I want to be notified, just as I was notified by the other policy, if these events occur, right? So this may be important if I'm processing data and I want to know certain values start shifting. This could indicate a problem. I could measure, hey, I want to know if I'm starting to get nulls in a certain field or an increased percentage of nulls, so I can get more insight into the data itself and see that over time. I can even look back at previous executions, etc. Now, a big part of understanding what's going on in your data is taking a look at the quality of the data, sort of the traditional data quality view. And we approach this in a perspective of having a business intent. We don't just check an attribute for a specific test, like is it null or is it in range? We build up a policy, a business intent of multiple rules. So for example, this could be a policy to say, this is the minimum data quality needed to process this transaction into our warehouse. So if this is a transaction, the GUID, the transaction ID, needs to be unique. The original transfer reference number should match a pattern that we define. The region ID needs to be in a certain range. Transaction type codes need to fit a certain set of values, right? All of these add up to say, this is the minimum data quality needed for us to process this, right? So we're able to then test all the rows needed, right? And I have a number of different execution methods here. I can test all the data out on your topic. I can keep a marker, so I just incrementally approach only test new data into the topic, or I can be very selective to say, here's a marker and a start and a stop, so I can take windows of data and test it, and even give you detail about the violations, details about which column, which message violated which rule, all the way down to that detail. So if you do have errors, your analysts can drive into the data and see what is actually failing in that approach, right? I can also take a look, back at past executions, so I can see how the data is evolving, right? Back on the 13th, we processed 3,000 messages through and had a failure rate a little under 0.5%. We were great 2 more runs, and then we again had some failures in the data. So again, I can look at this data as it's flowing through the topics. So now if I come back, talked a little bit about, I can have multiple policies assigned to this for different purposes. Policies are purpose-driven, right? I can also I can reconcile the data. So if I just pull in, say, this filter to say, just let me look at the reconciliation policies, I may want to confirm that, I take this data from Kafka and I push it into Snowflake, or maybe I push it also into Hive, and I want to confirm that the data from the Kafka topics did make it to Snowflake, and I want to confirm that it made it unchanged. So again, I can have a number of strategies around how I do that reconciliation. But one strategy is we call a data equality strategy. So basically, I define how I want to join, in this case on the GUID, between the transaction from Kafka to where I landed in the raw table in Snowflake. And then I've set up a series of tests. I want to ensure that, in this case, a transaction, the account number from, the company ID to, and the source amount is exactly the same. Nothing got changed along the way. A decimal point didn't get dropped. And I can do that for any number of the columns across. Again, setting a threshold for success or failure, as well as highlighting any potential rows or messages that failed this test, right? So I could identify data that is in the Kafka topic that didn't make it to Snowflake, or data that made it but somehow got modified. And I can, once I do that, I can have a lot more trust and faith in the data at the end of the process. Now, how hard is it to generate any one of these policies? Our goal is to make it incredibly simple to add coverage, reliability coverage on your assets. This, in my mind, is one of the #1 reasons people today have data reliability issues. It's getting coverage of these policy types on their data. So our goal is to make it incredibly easy to put this coverage in place, right? So I just click the option to add a data quality policy. I'm launched into our wizard. I give it a policy name. I can attach it to groups for management purposes. Because we've profiled the data, I showed you that shape of the data when we started. I've got quality recommendations. We understand the data. That's, hey, this data is almost never null, so maybe it's a required field, put a null check there. This data is almost always an integer, so we'll have a schema match there. We can go down and find other rule types that we know we want, right? So I can add multiple rules with simple clicks, again, aimed at getting a lot of easy coverage. And then I have a no-code approach to add other tests. The 6 dimensions of data quality, I call these table stakes. The key thing is to add these quickly and easily. And this is as simple as clicking a column and saying, hey, I've got this as an integer type or a date type or whatever type I want. And I can build that up into a series of rules. So again, I have a no-code approach to the common tests that we need, right? Range matches, uniqueness checks, a row check on a volume. I can predefine if I know for, say, a mandatory Boolean code, there needs to be, 2 different checks or 3 different checks. I can predefine that. I can drop into, I'll call these low-code rules. And this is as simple as saying, a Boolean expression, column 1 plus column 2 has to be greater than column 3. The sales tax must be less than the source amount on this transaction. I can actually get very complex with here. Here, it's basically the syntax would be an SQL syntax of, say, a Boolean statement like a where clause. And I can even drop into code if I need to. So you can predefine user-defined functions, right? If you have some special algorithm you need to test, we can predefine those and apply these in to our rules. So we give you a lot of flexibility, aim to be no code, and then allow you to drive that to code, right? I have a number of strategies around execution, execute it all against all the data in the source, have an incremental policy where we move through the data, where we keep a marker, or we'll give you the ability to do selective processing where you pick the start and stop point for any given execution, right? Now I can schedule all that so that it's an automated fashion, which is sometimes appropriate when you have an SLA and I want to know the data quality of this particular policy is tested at a certain time. For the lead in here, I may have a policy that's checking to see if I have new data every hour, and if not, I want to flush that, as well as the ability to trigger these policies externally, either through REST APIs or maybe through a pipeline that you're running where we provide SDKs so you can instrument your pipeline to trigger these policies. So it's very simple to, generate that, save it, and then you can put that on a schedule or have it attached to the policy. The other one I want to touch on is a reconciliation policy. Again, I think I spoke about this before, but if I go in to actually view one of these policies, I'll give you a sense of how we can generate those policies. All I'm doing is selecting the column that I want to test, the operator, the target column. As we've seen, we've built up these rules. We've set a threshold for success and warning, and then assigned weighting so we can get to fairly sophisticated scoring. The other elements of our ability to schedule the execution, turn on alerting so it goes to my email, it goes to the Slack channel, goes to a webhook, as well as defining persistence configurations, where I spoke earlier about showing you the actual data violations will allow you to persist those violations if you choose to a directory of your choice, an S3 bucket, a GCS bucket, ADLS or out to HDFS if you need to, as well as allow you actually to persist the good records. We have a client that is using this capability to actually segregate the data to say, hey, I'm going to send the bad data back to its source and continue to process the good data as we go forward. So at a high level, when I look at the data reliability, observability, the series of these reconciliation, data quality, data drift, schema drift policies all build up to allow me to have a high level of understanding and trust in the data that is flowing across my Kafka infrastructure, right? Because again, the data is the important part of what's flowing across Kafka, and getting from the source to the target and getting there in a reliable fashion is critical to the process. So now I want to switch over to talk a little bit more about the compute observability. How do I start looking at not the data that's flowing across it, but maybe the infrastructure that is supporting it? Because when I have a problem in this space, it could be a problem with the data itself, or it actually could be a problem with the infrastructure not processing the data. That data not showing up in the topic when I was expecting it may have something to do with the infrastructure. So I want to switch gears a little bit and talk about our compute observability. So now we have great in-depth, wide-ranging compute observability into the Hadoop Apache ecosystem. And this particular cluster, I can see it has a number of subsystems out there working as well, including Kafka, all running, very happy at the moment. But I want to do a deep dive into Kafka. Now, just like the data observability, the data reliability side, my entry point may not be coming to the dashboard and looking around. It may be from an alert that came to me through one of those channels that led me into the platform, right? So here, I'm just going to go to the starting point of saying, hey, I want to come in and understand what's going on in my Kafka infrastructure. So I come to my Kafka dashboard for this particular cluster, right? I could have multiple clusters and I can manage them all from here, but I have sort of a bird's eye view of what's going on. Or I have 4 brokers running, 1 live active controller, which is a good thing. We don't want a split brain syndrome with multiple controllers. I can see that there are no partitions offline, and I have no under-replicated partitions. So things look pretty good. Now I'm looking at this, say, for the last 24 hours, and I'm seeing here are the events that are happening, right? Where I have topics going from empty to stable. If I look back on time, we can see them going to empty, but I can see sort of what's been happening across the platform. I can start looking down to say, hey, do I have any imbalance between my brokers? Is one not getting any requests? Maybe that's going to lead me to say, hey, maybe my partitioning strategies are out of whack. I can start looking at the topic growth over time. Do I have 1 or more topics? And I can sort of filter these down. So maybe I really don't want the consumer offset in here because that kind of skews the view, but I want to see maybe the customer address and customer demographics topics, filter in this view so I can start zoning in on what I'm concerned about, what I want to keep an eye on, right? Again, giving me the bird's eye view that I'll be able to drill down farther and farther. I can see some change with respect to ISR expansion and shrinkage, and maybe that's something I'll want to go investigate what's happening with my in-sync replica sets. I can get a view of topic size with this, I think we call this a B swarm chart, where I can start seeing, hey, here's individual topics and their relative size kind of swarmed around, and I could actually drill right through to those topics from here, as well as start looking at the topic partition size, if there's skews or if there's lags by consumer group. So I can get a good bird's eye view of what's happening within my overall environment. Now, I may want to start drilling in, say, hey, let's take a look at the topics. I could drill to a specific topic, or maybe I want a bird's eye view of all the topics, right? So with that, I can start seeing all the topics I have, the partitions. This table is going to give me quite a rich view of items that I may want, or I could, adjust this and customize it. Maybe I want to just select all of them, apply, and I could quickly understand data in and out, what activities on any of these topics, right? And take a deeper look at any one of these. So if I drill into one, I can start seeing, this particular one has 12 different partitions. We're all in sync, 36 consumers, 3 consumer groups. I can see the rated data in and out, and I can start seeing a map of who's producing data into this topic, as well as what the consumers are, what groups are actually consuming data from the topic, right? I can start seeing statistics about the bytes in or processed or bytes per second. And as you might expect, it is the data out, because I have multiple consumer groups, is larger than the data in, right? And I can start seeing that message, see if I have any replica failures. And I can start taking a look at different partitions to see if there's lag by partition. I can see actually I do have some lag, a little bit. It just one message is not significant, but in a particular partition. Sorry. So I can, the theme here is I can start inspecting deeper and deeper into the topics themselves, of what's going on in the details. I can inspect actually some sample data here if I needed to. If I wanted to see actually what kind of data is landing in that topic. I can start taking a look at the topic partitions, how they're spread across the brokers, and then see, well, what's the ideal recommended distribution versus the actual. And it's actually saying, well, I've got this spread, these partitions spread across 3 brokers. There's a 4th one, and it's suggesting, I should change that and actually spread those partitions across to the 4th broker. So speaking about the brokers, I can start taking a deeper look at what's going on in the brokers themselves, and see if there's any imbalances across the brokers, and drill into the brokers and see what's happening on the systems themselves, right? So I can take a look at the CPU utilization from the brokers, disk utilization, see if anything's causing issues. Deep view into the JVM usage, garbage collection, the load on the broker, both the broker load and any system load that's going on, if there's any imbalances. And I could drill even deeper to look at the actual node overall, and all the processes happening there. As you can see, there was a spike in CPU utilization that's dropped off as we've gone along. So I can see the IO utilization and drill through all those elements, right? And I can drill down to actually the consumer groups to see what's happening within the consumer groups that are spread across the system, right? So I can see this particular consumer group, all the partitions, all the topics it's working on, if there's any lag by partition, the offsets they're working on. Again, drill very granular levels to understand what's happening if a problem is occurring, and investigate the events and understand what's happening across the platform. Now, the idea that you're going to go investigate across and have all this at your fingertips is great. But we talked before about alerts, right? So the idea is that the system should be monitoring these for you, and we should be able to be alerted when things happen. So we have a rich alerting framework that allows me to alert on any number of topics. So we give you sort of a library out of the box of alerts that you can implement. Say, hey, here's alert about active controllers. Only one broker must be controller in a cluster. Any other value is a problem. You could have brokers skewing, consumer lag. These are all out of the box events that you could monitor for and alert on. You can also create your own alerts by selecting the category, right? Selecting the metric, say that active controller count, right? The value, I want to count that active controller count should be equal to 1. That's all I want. If it's not 1, that's a problem. I can define alert thresholds, over what window to evaluate, how often to evaluate, how many times should it come up with this value before I call it an error, decide how I want to be notified. So we have a number of channels we support out of the box. And then, as Mark mentioned it before, I have the ability to have actions to be taken, right? So I can add an action and take a look at the actions that I have available. Here, I don't have particularly a large number, but I could. And again, you can create your own because we provide a framework for doing that, right? Simply, you could pass that along, and then I could give it a name and a severity type, a description, and then save that as my own alert, which would then get evaluated just like these other ones as we go through, right? Now, as I said before, there's the incident and alert frameworks. Alerts occur and they generate incidents, which again, were things that we're showing here where we are alerting you and then bringing you to an incident so you can track what's happening, which will then lead you to specific points in the platform to help you understand what's going on and take action if necessary. Now, we can also help you look, again, how Kafka exists within your overall cluster. So here I'm looking at all the nodes in my cluster, which are supporting lots of different activities. And I could then say, hey, I just want to look at the nodes that are in the Kafka, that are supporting Kafka, and I can get a view of the utilization and hotspots within it. I can see this first node during this period of time experienced higher CPU utilization. And, I can start drilling in again to get a very deep view of what was going on in that node at that time, and try to understand what was driving the situation, right? So I can start looking at what elements were causing the CPU utilization, breaking down by Kafka here, node manager, region servers, and really start drilling into understanding what drove any of the events in the node at that time. So I've kind of done a whirlwind tour through both our data observability capabilities for Kafka topics, right? As well as our compute observability for the infrastructure that's running. It's the combination of having observability into both aspects that helps you answer the questions quickly of, is my data coming across reliably? Is the infrastructure operating appropriately? And how can I optimize things as I go forward? So hopefully, I'm not sure if that's generated any questions. That's about taking about 30 minutes, which was my goal for the demonstration. So I'm going to pause now and see if we have any questions queued up. Mark or Loretta, do we have any questions queued up? If you have questions, there's a Q&A section, which we'd love for you to pop them into.
Yeah, Joe, we do have a few. So let me read them out, and then you or Mark or Shubham can answer the question. So the first one is there integration support for open source Kafka and Kafka running on Kubernetes?
Shubham, you want to grab that one?
Sure, Joe, thanks. Yes, so we do have an integration support. So with Kafka ranging versions from 0.10.2 to Kafka latest version 3.1, 3.2. So even we connect with distributed Kafka that comes in as well as the open source one. And the platform on which it is running, if it is an on-premise or whether it is in Kafka on Kubernetes, we do support both data and compute observability for those platforms.
Okay.
Great, thanks, Shubham. Mark or Joe, you want to add anything else?
I'm sorry. Yeah, so along with the compute observability, then we can layer on top the data observability onto those platforms. And we support from that perspective, both, you know, the open source Kafkas as well as Confluent Kafka to do data observability and reliability on top of.
Yeah, and the data observability for reliability and inspecting the data, as Joe has shown, goes beyond just the Kafka environment. So for reconciliation and even the data quality rules and others, you can look at that both on batch data as well as the streaming data in multiple environments.
Thanks, Mark.
All right, we'll move on to the next question. The next question is, are there any Kafka version limitations and what changes are required to enable observability?
Go
Yeah.
ahead.
So there's no specific Kafka version limitations besides using an older Kafka versions, 0.8, 0.9, because they do come with the deprecated API support. So that kind of blocks some of our charts and dashboards to kind of not show some of the metrics. But besides that, there is no limitation on any Kafka specific versions. Yeah.
Okay.
Okay, great. The third question that we have is there an option to create custom alerts or studio dashboards for self-reporting and monitoring?
Right. So as Joe was already giving us the walkthrough around it, so we do collect all the metrics from the system and from the platform as well, including the Kafka service and on the infra which Kafka gets hosted. So we collect those metrics and store on our backend data stores. And we provide you the option that you can exploit those metrics to create your own alerts, create customizable alerts, or you can request for any features or something that you need as an alerting option for raising the incidents in your respective notification channels. So it is quite easily feasible and available in the platform and in the Pulse. And from the studio or creating any kind of a customized reports, for example, you're monitoring some network latencies or any kind of a follow or replication rates, anything which is not part of our usual widgets and dashboards. We do provide a kind of a studio in which you can create your own charts, you can create your own visualizations, and you can also get a reporting mechanisms that it could generate and show you any kind of anomalies, and it sends it over to you on the mail. Yeah.
Yeah. And I'd add on from the data reliability side, the policies themselves you can consider sort of a customized alert, because we'll alert on the execution of those policies, right? So just like you may be looking to alert on some trend in the infrastructure, the policies allow you to create those customized alerts on the trends or events in the data itself, right? And so the act of creating those policies in essence are customized because they're aimed at delivering a business intent, and that becomes a customized alert for the data reliability side of the house. And all of that data is available to you if you wanted to, after the fact, pull that data out of our repository and do custom analysis for it. We deliver all the results to you in a number of formats.
Great, thanks, Joe. And I think this is the last one that we have, unless another one comes in. And this last one is just, what does it take to implement or install Acceldata right into my Kafka environment? What does that look like, and how long does that take?
So I'll let you start, Shubham, with sort of from a Pulse perspective, what it takes to add, and then I'll add on the data reliability perspective.
Right. So from compute observability, as in Pulse, to deploy and monitor your Kafka services, as well as the topics and the objects level monitoring and health, So we request a server and the product gets deployed on the on-premise solution, or you're having infra on the cloud. So we request a server basically on which we host our Pulse component and all these services. And it basically connects to your Kafka brokers, to your channels. So it needs a network connectivity over there. And the installation is really very smooth. It goes with a specified steps as available in our public documentation channel. We'll share with that. And it hardly takes like a 1 hour to 2 hour to complete the installation itself.
Thanks, Shubham. From a data reliability perspective, that application we deploy actually into a Kubernetes cluster. Could be in one of your cloud providers in their managed Kubernetes infrastructure, could be on-prem. The idea there is you're going to set up this infrastructure to monitor your entire data landscape, not just your Kafka data landscape, because that's where you get the incredible value as you start watching that data flow across your landscape. There, the onboarding of the Kafka is simply creating a data source, having the network connectivity, and having the proper credentials set up. So it's a very short configuration wizard, a couple of steps, 4 steps, I think. It then connects to your Kafka cluster as a client. It scans for all of the topics, then inspects data on the topic and can infer the schema. If you have a schema registry, it'll read the schema registry to get the information about the messages on the topic. If you don't, we'll actually inspect the messages and infer a schema. So that's a very quick process. And then once we start doing these policies, essentially what we do is spin out a Spark workload in that Kubernetes cluster to connect to the topics, gather the data, run the execution policies, or connect to multiple sources if we have to do a reconciliation. So again, a very structured installation process. Kind of depends on what infrastructure you're going into, but again, all documented on our website as Shubham mentioned.
Great, thanks, Joe. It looks like one of the participants has raised their hand. If you did have a question, please put the question in the Q&A, and then we can answer it. So let's just give, if you're interested in asking a question, again, we'll give you a couple minutes, or excuse me, a couple seconds to type it in the Q&A, and then we can answer the question for you. Nope. Okay. So I don't see any questions in the Q&A. So yeah, feel free to email us afterwards if you did have a question that we did not answer. But I think that kind of concludes the webinar for today. I think, Mark, you have one more slide, or a couple more slides. So yeah, so thank you so much for your time today. Appreciate it. We know that your time is valuable. One thing we did want to have you to be on the lookout for is each of you will receive a $50 Amazon gift card via email. So if you did provide a legitimate email when you signed up for the webinar, look out for that in the next couple days. And if you are going to the Current Summit next week, drop by our booth. We are in S21. We'd love to see you and continue the conversation. So again, thanks so much for your time, and we'll reach out to you to check your interest. Appreciate it. So thanks very much, everyone. Have a great day.